Indices and logarithms. Now, in previous videos, we looked at indices. Alright? Now we're going to look at logarithms. I don't just call it logarithms because we're going to see how it is related to indices. So this is indices and logarithms. We're adding logarithms to what we learned so far about indices. Now, let me see something here. Let us look at this. Suppose you use your calculator to find log, say log 1. What would you get? Let's draw for our calculator and see something here. Calculator. Alright. Remember, it's log that we're looking for. Log. Log 1 equal 0. You get 0. Let's write that down. Let me see something here. I want my calculator as it is. Alright, I don't want to take up too much space. Let me fix up my calculator as I want it. Alright, nice. So, log 0, log 1 is 0. Write that down. The logarithm of 1 is 0. Suppose we find log 10 and we find out what that is equal to. Calculator again. Log, where's log again? Log 10 equal. We get 1. So we get 1 this time. 1. Suppose we want log 100. We say equal. Those are good dots. Let's get rid of them. Alright. Calculator. Back to our calculator. This is the calculator I want. So we say log 100 equal 2. So log 100 is 2. So we write 2. Suppose we find log 1000. What would we get? Getting interesting. Are we seeing some sort of pattern somewhere? Let us see. Log 1000 equal 3. Well, no. Log 1000 is 3. Suppose we try log 10,000 equal. By the way, before we try, let's see something here. When we have log 1000, we get 3, and there are 3 zeros in 1000. When we have log 100, we get 2, and there are 2 zeros in 100. When we had log 10, we get 1, and there is 1 zero in 10. And when we found log 1, we get 0, and there is no 0, 0, 0 in log 1, in 1. So let me see something here. If we find log 10,000, what would happen? I'm going to guess that we're going to get 4 because there are 4 zeros in 10,000. We try it now, and see what happens. This is going to be interesting. Now we find log 10,000 equal 4. We get 4. Well, no. So this has something to do with 10. Now, let me look back at my calculator. It might be different from the scientific calculator you have. But I see here, log, logarithms. Now, if you look on your calculator, whether it's Sharp or Casio or some other brand, and you look at log, above log, you're going to see 10 to the power of x. Right? Now, if we have 3 and, well, it wouldn't work out like your calculator. You'd have to say log inverse of 3 equal. How would it work here? Say logarithm of the logarithm inverse. I don't see any shift or second function on my calculator. If you're using a scientific calculator and use shift or second function and 3, you should get 1000. Right? Now, if I have 10 to the power of 3, I get 1000. Right? 10 to the power of 3 is 1000. 10 to the power of 4 equal 10,000. 10 to the power of 4 is 10,000. Right? Now, there is something having to do with 10 when it comes to this log business. What it has to do is that these logarithms are logarithm with a base of 10. Right? It's log with base 10. So let me write down the base. Let me say the base is 10. Logarithm with base 10. All of these logs are log with a base of 10. Now, we also know that 10 raised to the power of 4 equals 10,000. We know that 10 raised to the power of 3 equals 1000. We know that 10 raised to the power of 2 equals 100. You remember your indices? You have to remember your indices and understand your indices to know these things, 10 raised to the power of 1 is equal to 10. And 10 raised to the power of 0 equals what? You remember? Equals 1. When you raise a number to the 0, you get 1. When you raise a number to the 1, you get the number itself. And so on and so forth. Remember, 10 to the power of 2, you call it 10 squared. It's 10 times 10. You have two 10s lined up and they multiply each other. 10 to the power of 3, which you call 10 cubed, means you have 3 10s. You line them up, multiply all of them, and you get 1000. 10 to the power of 4 means you have 4 10s lined up, multiply all of them, and you get 10,000, and so on and so forth, right? Now, the thing is, you notice you can form some pattern here. 10 to the power of 0 equals 1, right? 10 to the 0 equals 1. You see that? 10 to the 1 equals 10. 10 to the power of 1 equals 10. See that? And so on and so forth. 10 raised to the power of 2 equals 100. 10 to the 2 equals 100. And sure you see that. So the pattern 10 to the 3 equals 1000. 10 raised to the power of 3 equals 1000. Right? 10 to the power of 4 equals 10,000. 10 to the 4 equals 10,000. Alright, so here now, we see that when you have this case 10 to the power of, let me concentrate on 10 to the power of 3. 10 to the power of 3 is equal to 1,000. These are in exponential form, right? exponential form, which we also call index form. In this case, 3 is the power or the exponent or the index. 10 is the base. Now these statements are in the Logarithms logarithm EHMIC form, in log form, logarithmic form. Alright? Logarithm Logarithme. I was spelling it wrong. Let me erase and respell this thing. Logarithme. Logarithmic form. No, I spell it right. There's no E in it. Logarithmic. Alright, good. Sometimes these spelling can be mixed up. But anyway, you have logarithmic form on the left, and you have the exponential form on the right, sometimes called the index form on the right. Now, 10 is the base of the logarithm here. 10 is the base of the exponential of the exponent here. So basically, when you have the base raised to the power of a number is equal to what you get as the base. No, let me write P for power, right? Base raised to the power equals a number, the base of the index raised to a power, or the base of the exponential form raised to a power equals a number. Then when it comes to logarithms now, the log of, now notice we're going to rewrite from exponential form to logarithmic form. In other words, from index form to log form. Let's concentrate on this one. The base is 10. The base of the exponential form is 10. The base of the log is 10. Right? So we have the base of the log. Then after that, we see that the index is 3. And the answer here is 3. See that? Now, the index is P. See? So our answer here is P. And then the answer here is 1,000. But the number you're finding the log of is 1,000. The number you're logging is 1,000. Now the answer here is N. So the number you're logging must be N. Alright? So here, generally, you find the log of a number and the log has a certain base, you get your answer P. Alright? The log of n is the log of n, right? Is the number that the base of the log must be raised to get that number. The log of n is the number that the base of the log must be raised to. This is the number, you know. In order to get n. That's one way. This is just my way of saying what the logarithm of a number is. Let me just type it. I don't want to try and write it. Let me just type it here. So, the logarithm of a oh no, what's going on? Accident. Alright. Of a the log number. The logarithm of a number. Right? The logarithm of a number is the power that the base of the logarithm, that the base of the logarithm must be raised to get that number. Let me put here, in order to get that number. That is just my made up definition of logarithm. You can find various definitions in books, websites, and so on. But here, the logarithm of a number n, the logarithm of the number n is P. You see that? Now, the logarithm of the number n is the power that the base of the log must be raised to in order to get that number. You raise the base of the log to the power and you get the number. Right? This is the logarithm of n, where the log has this base. Right? This P here is the logarithm of n, where the base of the logarithm is b. Alright, now here we see the relationship between indices and logarithms. And remember, if you are asked to rewrite an exponential form, an index form, an equation that is in an index form, to rewrite it in log form, what you do, in order to remember what to do, you say, my, I don't remember, you know? And I'm not allowed to look in any book because we're in exam. So what do? You say the index form, the log form. Index form is 10 to the 3 equal 1000. But you have your calculator in front of you and you find the log of 1000. And you get 3 and the base is 10. And you say, nice. Just rewrite this in this way. Whatever number you're raising to the power is the base of the log. In this case, 10. The power, or the index, when you write it in log form, is going to be the answer. So the number you're raising to the power is the base of the log is 10. the index, which is 3. In log form, it will be the answer. And the answer in index form or exponential form is really the number that you're logging in log form. Alright, so those were the relationship between indices and logarithms. So we continue next time in our next video. So I will see you then.